preparing for an AI product manager interview. You've reached Interview Guide, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you define a successful AI product? A successful AI product solves a real user problem where intelligence creates measurable leverage, not novelty. I define success to user outcomes, model quality, business impact, and operational reliability. For example, a support copilot should reduce resolution time, improve CSAT, and maintain low unsafe response rates. I also separate offline metrics from production metrics because a great benchmark score can still fail in workflow adoption or trust. While answering, focus on user value, business outcomes, model performance, reliability, trust, and adoption. Make clear that AI success is not just benchmark accuracy, but measurable product impact. Question 2. How do you decide whether a product problem actually needs AI? I start by asking whether the task requires prediction, generation, ranking, personalization, or pattern recognition at scale. If a rules-based solution is cheaper, reliable, and explainable, I would use that first. AI is justified when variability is high, data is available, and the business value outweighs model cost and risk. I also validate whether users can tolerate probabilistic behavior, because some workflows need precision more than automation. Make sure to cover problem framing, deterministic alternatives, uncertainty, data availability, cost, latency, explainability, and user tolerance for errors. Interviewers want disciplined judgment, not AI-first thinking. Question 3. What metrics would you use to evaluate an AI-powered search or recommendation feature? I would use a layered metric framework. Offline, I would track precision, recall, NDCG, coverage, and diversity, using labeled or behavioral data. Online, I would measure CTR, conversion, session depth, retention, and user satisfaction. Guardrails matter too. Latency, filter bubbles, complaint rates, and fairness across user segments. The key is not optimizing relevance alone. A recommendation system should improve user outcomes and business value without narrowing discovery. In your answer, talk about offline model metrics, online product metrics, business KPIs, guardrail metrics, experimentation, and feedback loops. Include examples like relevance, CTR, retention, diversity, and latency. Question 4. How would you prioritize features on an AI product roadmap? I prioritize AI features using impact, confidence, effort, and risk, but I add AI-specific dimensions: data availability, model feasibility, evaluation difficulty, inference cost, and trust risk. A feature with high user value but no labeled data may need a discovery milestone before full build. I also sequence foundational work, like logging and evaluation pipelines, before flashy UX. Strong AI roadmaps balance customer-facing wins with platform capabilities that compound over time. Be sure to mention customer pain, expected impact, feasibility, data readiness, model complexity, cost, risk, and dependencies. Show how AI roadmap prioritization differs from normal feature prioritization. Question 5. How would you work with data scientists and ML engineers to launch an AI feature? I would align the team around the user problem, target behavior, constraints, and success metrics before discussing models. With data scientists, I would define labels, evaluation sets, baselines, and acceptable error types. With ML engineers, I would clarify latency, scalability, observability, and deployment requirements. My role is to translate business and user goals into technical priorities, remove ambiguity, and ensure the launch includes monitoring, rollback plans, and feedback loops. While answering, cover cross-functional collaboration, problem definition, success metrics, data requirements, model evaluation, product constraints, launch planning, monitoring, and iteration after deployment. Question 6. Explain the difference between model metrics and product metrics. Model metrics measure how well the algorithm performs on a defined task, such as accuracy, F1, AUC, BLEU, or hallucination rate. Product metrics measure whether users and the business benefit, such as activation, retention, conversion, CSAT, or time saved. The two are connected, but not identical. A model can improve F1 while users ignore the feature. As a PM, I tie model improvements to product outcomes and validate them through experiments. Make sure to distinguish technical performance from user and business impact. Include examples, why offline metrics can mislead, and how production behavior should influence iteration decisions. Question 7. How would you handle hallucinations in a generative AI product? I would first classify the risk of hallucination by use case. A creative writing tool can tolerate more errors than a medical or financial assistant. To reduce hallucinations, I would use grounding through retrieval, constraint generation, citations, better prompts, eval datasets, and refusal behavior for low-confidence answers. Product design also matters. Show sources, allow feedback, and avoid overclaiming certainty. For high-risk workflows, I would add human review or limit the model's scope. In your answer, discuss risk classification, grounding, retrieval, prompt design, confidence signals, human review, user experience, monitoring, and clear limitations. Mention that acceptable hallucination rates depend on use case. Question 8. How would you evaluate whether to build, buy, or partner for an AI capability? I would build when the capability is core to differentiation, we have unique data, and customization creates durable advantage. I would buy when the capability is generic, speed matters, and vendors meet cost, privacy, and quality needs. Partnering works when domain expertise or distribution is complementary. I would also evaluate vendor lock-in, model performance, security, roadmap control, and total cost at scale. The right decision can change as the product matures. Be sure to cover strategic differentiation, time to market, cost, data advantage, customization needs, vendor risk, privacy, compliance, and long-term maintainability. Give a balanced decision framework. Question 9. How do you design a user feedback loop for an AI product? A strong feedback loop captures both explicit and implicit signals. Explicit feedback includes thumbs up, corrections, ratings, and reported issues. Implicit feedback includes edits, abandonment, repeat usage, dwell time, and downstream task success. I would make feedback easy, collect context, and avoid overweighting noisy signals. Then I would route feedback into dashboards, evaluation datasets, and model improvement pipelines. Users should also see that feedback matters, which builds trust and engagement. While answering, focus on explicit feedback, implicit behavior, labeling quality, feedback bias, model retraining, monitoring, and closing the loop with users. Show how feedback improves both product and model. Question 10. What are the biggest risks when launching an AI product? The biggest risks are unreliable outputs, user mistrust, bias, privacy violations, security vulnerabilities, and runaway serving costs. There is also product risk. The AI may be impressive in demos but weak in real workflows. Operationally, models can drift as data changes, and teams need monitoring and escalation paths. I mitigate these risks with phased launches, guardrails, evaluations, human review for sensitive cases, transparent UX, and clear ownership after release. Make sure to include technical, product, ethical, legal, and operational risks. Mention hallucinations, bias, privacy, security, cost overruns, poor adoption, model drift, and unclear accountability. Question 11. How would you run an A/B test for an AI feature? I would start with a clear hypothesis, such as whether an AI writing assistant reduces time to publish without lowering quality. Then I would define primary metrics, guardrails, and target segments before launching. Randomization must be clean, and sample size should account for variance. Because AI output quality can vary, I would monitor safety, latency, complaints, and edge cases during the test. I would also inspect qualitative feedback, not just aggregate lift. In your answer, discuss hypothesis, treatment design, randomization, success metrics, guardrails, sample size, novelty effects, segmentation, and ethical constraints. Explain why AI experiments may need extra monitoring. Question 12. How would you explain model drift to a non-technical stakeholder? Model drift means the world changes after the model is trained. so its predictions become less reliable. For example, a fraud model trained on last year's patterns may miss new attack methods. The business impact could be more false approvals or blocked good users. I would explain that AI products need ongoing monitoring, not one-time launch. We track performance indicators, compare data distributions, retrain when needed, and keep fallback procedures ready. Be sure to give a simple definition, practical example, business impact, monitoring approach, and mitigation options. Keep the explanation accessible while showing technical understanding. Question 13. How would you create requirements for an LLM-powered customer support copilot? I would define the copilot around agent workflows, not just chat. Requirements would include retrieving approved knowledge articles, summarizing customer history, drafting responses, citing sources, respecting permissions, and escalating uncertain cases. Success metrics could include handle time, first contact resolution, CSAT, agent adoption, and unsafe answer rate. I would specify latency targets, audit logs, data privacy constraints, and evaluation criteria. The goal is to augment agents while preserving accountability. While answering, cover user personas, workflows, grounding sources, response quality, permissions, latency, escalation, compliance, success metrics, and failure modes. Show structured product thinking. Question 14. What is RAG, and when would you use it in an AI product? RAG, or Retrieval Augmented Generation, combines search with generation. Instead of relying only on the model's training data, the system retrieves relevant documents and uses them as context for the answer. I would use RAG when the product needs current, private, or domain-specific knowledge, such as policies, manuals, or customer records. It helps reduce hallucinations and improves traceability. The trade-off is that retrieval quality, permissions, and latency become critical product requirements. Make sure to define Retrieval Augmented Generation. Explain grounding, freshness, proprietary knowledge, hallucination reduction, architecture basics, and limitations like retrieval quality and latency. Question 15. How would you balance personalization with privacy in an AI product? Personalization should feel useful, not invasive. I would collect only the data needed for clear user value, explain how it is used, and provide controls like opt-out, deletion, and preference editing. For sensitive data, I would consider anonymization, aggregation, retention limits, access controls, and privacy-preserving methods. I would also work with legal and security early. The best AI products earn trust by making personalization transparent, controllable, and proportional. In your answer, talk about user value, consent, data minimization, transparency, controls, anonymization, retention, compliance, and privacy-preserving techniques. Show that trust is a product requirement. Question 16. How do you decide the right level of human-in-the-loop for an AI workflow? I choose human involvement based on risk, reversibility, confidence, and user expectations. Low-risk tasks, like tagging photos, can be highly automated. High-risk tasks, like approving loans or medical recommendations, need human review, explanations, and audit trails. Many products start as assistive copilots, then automate narrow steps once quality is proven. Human-in-the-loop is not just a safety mechanism. It can generate labeled data and build user trust during adoption. Be sure to discuss risk level, reversibility, confidence thresholds, automation benefits, user trust, cost, compliance, escalation, and gradual autonomy. Differentiate assistive, review-based, and fully automated workflows. Question 17. How would you price an AI product or AI feature? I would price based on customer value while respecting AI cost structure. If the feature saves hours or increases revenue, value-based packaging may work. If usage drives variable inference costs, usage-based pricing or credits can protect margins. For enterprise buyers, predictability matters, so tiers with limits may be better than pure metering. I would model gross margin, expected adoption, abuse risk, and willingness to pay. Pricing should encourage usage without surprising customers. While answering, cover value-based pricing, usage-based pricing, cost of inference, customer willingness to pay, packaging, margins, predictability, and enterprise needs. Mention that AI economics differ from traditional SaaS. Question 18. How would you evaluate fairness and bias in an AI product? I would evaluate fairness by checking whether outcomes differ unfairly across relevant user groups. That starts with understanding the domain, protected attributes, data representativeness, and historical bias. Then I would compare metrics across segments, such as false positive rates, recommendation exposure, or approval rates. Quantitative checks should be paired with qualitative review and stakeholder input. Bias cannot be eliminated completely, so the product needs mitigation plans, monitoring, documentation, and escalation paths. Make sure to cover protected attributes, representative data, subgroup performance, fairness metrics, qualitative review, mitigation, monitoring, and legal or ethical constraints. Avoid claiming bias can be fully eliminated. Question 19. How would you launch an AI feature from beta to general availability? I would use beta to validate product value, quality, safety, and operational readiness. I would select customers who match target use cases and are willing to give structured feedback. Before GA, I would require clear success metrics, stable latency, acceptable error rates, support playbooks, documentation, security review, and monitoring dashboards. GTM should set accurate expectations about capabilities and limitations. After launch, I would keep iteration cycles tight because AI behavior evolves in production. In your answer, discuss beta goals, customer selection, readiness criteria, quality thresholds, documentation, support training, monitoring, go-to-market, pricing, and post-launch iteration. Question 20. Tell me about a time you would say no to adding an AI feature. I would say no when AI adds complexity without improving the user outcome. For example, if customers need a reliable approval workflow, a transparent rules engine may be better than a probabilistic model. I would also reject AI when data is insufficient, risks are high, costs are unjustified, or the feature distracts from core priorities. Saying no is not anti-innovation. It protects trust, focus, and resources for use cases where AI truly compounds value. Be sure to frame this as a product judgment question. Discuss opportunity cost, user need, deterministic alternatives, risk, data gaps, cost, trust, and strategic focus. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.